Okay. Matthew, can you tell me please the last point where we are left in the last classes?
Yeah, 1 second, sir. The last point we were at.
I think
Give
it
me the
was a
question,
question
sir.
on
Yeah.
superposition law.
Yes, sir. Yes, sir.
What is the question? Tell me please.
Two charges, positive and negative, are placed in two separate positions. Calculate the position of Q so that Q is in equilibrium.
In equilibrium, right? In the last.
Yes.
Then the another third charge, capital Q, should be small q in equilibrium, right?
Oh, yes, sir. Yeah, yeah.
The final answer is x by 3 or a by 3, just like this. Okay. Okay. Now, today we are going to discuss about the electrical field lines. Okay. Our today's topic is electric field lines. Electric field lines.
So which chapter?
Okay. Yeah, this is a chapter first, electrostats, right? It is another topic, which is electric field lines, right? Are you clear?
Yes, sir.
Yeah. Electric field lines. The concept of electric field lines was given by Michael Faraday. It is generally as imaginary concept, okay, which was used by the Michael Faraday to represent the space or field of a charge. Are you clear? Now you can write here. It is an imaginary concept. It is an imaginary concept imaginary concept of visualizing electrostatic field okay, graphically. All right, graphically. Okay, in electric field lines, what are the electric field lines? It is an imaginary concept which was used by the Michael Faraday to visualize the electrostatic field graphically. Are you clear? It was introduced by Michael Faraday. Okay. Now, what are the properties of the electric field lines? The properties of the electric field lines are, first of all, they EFL in the sense electric field lines. Are you clear? It is short form of the electric field lines. Electric field lines starts from positive charge and terminate at negative charge. Electric field lines starts from positive charge and terminate at negative charge. Just like if you have a positive charge like this, then the electric field lines are always in away direction from the charge. Okay. These are in away direction. All right. Just similarly, if you have a negative charge, in that case, electric field lines seems to be terminating at the surface of the charge, just like this. Okay, please note it down. Positive charge is also sometimes called as source charge. And negative charge is also known as the sink charge. Note it down, please. All of you have noted it or not?
Yes, sir.
Noted.
Should we move on?
Yes, sir.
Matthew, Gauri, Nawal, Zarsh, all of you have noted it?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
Now the next point is that they never intersect each other. I means electric field lines never intersect each other. Okay, you can draw like this. This is your electric field lines of any charge of Q1, and this is the electric field lines of any other charge of E2. Okay, so we can say in the same space, infinitely many lines can flow. Are you clear? They never disturb each other. The third point is density of electric field lines gives ideas regarding strength of electric charge. Density of electric field lines gives idea regarding strength of electric charge. Okay. Sorry, regarding strength of electric field. All right. Suppose that you have some field lines like this. You have, you can take a point at the position A or position 1, you can also say. This is your E1, and at this position, the field lines are very far, okay, from each other. So you can take electric field lines like E2. In this case, the stronger fields are represented by electric field lines which are closer with each other. Okay, electric field lines are closer, and where the electric field lines are far apart. Okay, I mean in this region electric field lines are far apart, so this region is said to be the weak field. Electric field lines are far apart. Okay, or in mathematically you can also say E1 is greater than E2. Okay, you can also write it. Please note it down.
Finish, sir. Sir, one doubt.
The next point is direction of electric field is tangential to the field lines. Suppose that you have a field lines like this. Sorry, you have a field lines like this, and you want to calculate the direction of electric field lines at this position. Then you should draw a tangential line, okay, at this point. And this tangential line gives you the direction of electric field lines at that point. Okay, you can see here at each and every point the direction of electric field lines is different. So you have to write here direction of electric field, direction of electric field lines, direction of electric field is tangential, to the field lines. Okay, also make it E. This is also the direction of E. This is also the direction of E. Okay, note it down. The another point, electric field lines are continuous curves. And continuous and open curves. Like they never form a closed loop. They never form a closed loop. Are you clear? Just like this. Electric field lines always be like this curve. Okay. It never be. Okay. It is not possible like this. Okay. You can look at here at this position. It is a discontinuity. Are you clear or not? It is not possible, and this one is possible. Okay. Note it down. All of you have noted it?
Yes.
Yes, sir.
Okay. The next point is, suppose that you have two field lines like this. Okay. Like this. There are two field lines are given like this. This is your field lines of one. This is your another field lines. Okay. This means that it is just like looking a repulsive nature. Are you clear or not? They are repelling each other. This means that these two field lines are generated from the like charges. Either it may be the charges of positive or it may be negative. Okay. Are you clear or not? So we can say they exerts lateral pressure. You can say also they exerts lateral pressure, which explains repulsion. Okay, which explains repulsion. Also, in both of these two field lines, there always be, okay, it always be possible that there is a line at which the net effect is 0. So this line is said to be the neutral line, or you can also say there is a point, which point is said to be the neutral point. So you can also write here neutral point. What is the neutral point? It is a point at which net field is 0. Okay? It is a point at which net field is 0. Are you clear? Are you clear or not? And it also remember that electric field lines never cross neutral point. Never cross neutral point. Okay? Are you clear? Note it down, please. The next point is, all of you noted it?
Yes, sir.
Yeah, okay. The next point is electric field lines never penetrate into the conductor. Okay? It never penetrate into the conductor. I means electric field lines always starts from surface of charge. Okay? Electric field lines always start from surface of charge and terminates at the surface. Means they never enter into the they never enter inside the conductor. Just like you can take a conducting body like this. Suppose that this conducting body is positively charged. In this case, the electric field lines always start from the surface. Okay? It always starts from the surface, and it starts from the surface like this. Okay? And just similarly, if you have a negative charge, in this case, it always terminates at the surface. Okay? I mean, it never enter inside the conductor. Are you clear or not? All of you are clear or not? Okay? Please note it down, this point also. The another, just one second, please. The another point in this is also, okay, electric field lines are always perpendicular to the surface. Perpendicular to the surface. perpendicular, okay, to the surface. What does it mean? It means that all of the electric field lines either going away from the charge or terminating at the surface of the charge. It always makes 90-degree angle from the surface like this. Okay, you can look at here. It is 90-degree. It is also 90-degree. Okay, just similarly, it will be 90-degree. All of the field lines always make 90-degree angle from the surface. Are you clear or not? So please also note it down as well. Please note it down. All of you have noted it or not? Hello? Hello?
Yes, sir. Noted down.
All right. Okay. The next point is, sorry, we have another question. Please note it down. Draw electric field lines for isolated positive charge, B for isolated negative charge, C for electric dipole. Sorry. Please don't write about electric dipole. Yeah, C, two equal positive charge, D for the uniform electric field. Uniform electric field. Okay, please draw all of the electric field lines, please. All of you can draw it or not? All of you are doing or not? Hello. Hello, Matthew.
Doing, sir, doing.
Yeah, okay. Matthew, Nawal, Zarsh, Gauri. Yeah, please do this. Your solution is for isolated positive charge. In the sense, this is your positive charge and the electric field lines are just like this. This is your part A. Part B is isolated negative charge like this. You can draw the electric field lines. This is your answer. For C, two equal positive charges. This means these are the two positive charges and the electric field lines are passing like this. Okay. But you have already know two like charges repel each other. So the electric field lines generating from these two charges are also repelling each other. Okay. I mean, just like they are exerting pressure on each other. Okay. So this is your part C. And what is the D? Uniform electric field. Uniform electric field in the sense the magnitude of field is equal at each and every point. I means electric field lines are parallel from each other. Okay. This denotes uniform electric field. Note it down, please. Check it out. All of you noted it or not? Hello? Hello?
Yes, sir.
Yeah, okay, good. And now the next heading is electric field. Electric field. What are the electric field? Okay. Electric field is a space surrounding a charged particle in which electrical effect can be observed, right? What is the electric field? It is the region surrounding a charged particle, in which electrical effect can be observed. Are you clear? Suppose that you have a positive charge like this. In this case, surrounding this charged particle, depending upon the magnitude, it creates a region. Okay? It creates a region surrounding itself, in which you can observe the electrical effect if you put another charge. All right or not? You can write here, this is the field of this charged particle. And in this field, if you are carrying another charged particle, then you observe the electrical effect. I mean that charge either we repel from this charge or attract towards this charge. Okay. Suppose that you have this charged particle like Q naught. In this case, suppose that if both of the charges are positive, then this capital Q charge repel the small q charge. And this charge, I mean this smallest charge, is said to be the test charge. This charge is said to be the test charge. Okay. The direction of the force is this. And the charge placed at the center is said to be the source charge. All right. It is also important to remember here, electric field is a property of single charge. It is the property of single charge. Are you clear? Please note it down. All of you noted it? Should we move on? Okay. The another point we are going to understand about this test charge. What is the test charge? What are the test charge? Remember here, test charge was introduced just only for to justify the electric field. Are you clear? Or to measure the electric field strength within a field. Okay. Test charge is always infinitesimally small. Infinitesimally small. Okay. If the test charge is very small, in that case, the effect of that charge also be small. So we can say, if you want to check the field of any other charge, then test charge can be used. Are you clear or not? Because the magnitude of test charge is very small, causing which it never disturbs the field of the source charge. Instead of it, it also gives the whole of the informations about the field of that source charge. Are you clear? So it is said to be the test charge. Are you clear or not? Are you understand it?
Yes, sir.
Yeah. And now the another point is electric field intensity, or you can say electric field strength. How can we measure the electric field strength within a field? Okay. Electric field strength. Electric field strength. Okay. Suppose that you have a charged particle like this. You have a charged particle like this of magnitude of plus q. Plus q charge. And now this charge creates a field surrounding itself like this. You can draw like this. This is the field of this charge. And now if you are put a point charge at this position, I mean point charge in the sense, point charge is also known as the test charge. Then what will happen? Then this source charge start to repel the test charge in away direction. And now in what magnitude? Are you clear? Or we can say in what amount of force this positive charge, I mean this source charge, are repelling test charge. Okay. That magnitude is said to be the strength of the electric field. Are you clear? The direction is always be in this direction. Okay. This is your source charge. This is your source charge. Okay. Now you can look at, you can write here measure of measure of strength of the field, strength of the field at a point. Okay, measure, it is the measure of strength of the field at a point. Are you clear? Now what will happen if you are keeping the another test charge at this position? In this case, you can understand here the separation between the position B and the source charge is very small. Then we can say the magnitude of force acting upon the charge placed at the point B due to the source charge always be greater, okay, as compared to the position A. Hence we can say that at each and every position it may possible that this means we can say for different radius or for different separations from the source charge, the strength of the field always be different. So the main question is that how can we measure it? Okay, then please note it down. To calculate the strength of the electric field, we can calculate it like E is equal to limit of Q tending to 0. What is the Q tending to 0? This is your test charge, which is equal to, Q tending to 0, Q tending to 0, F over Q. What is the F? F is your Coulomb force. F is your Coulomb force, okay? Or you can also say force experienced by test charge. Are you clear? The main point is that it is valid. This concept is valid for all type of configuration. For all type of charge configuration. Okay. What will be the unit? The unit will be, what is the unit of force? The unit of force is Newton and the unit of charge is Coulomb. So the unit is Newton per Coulomb. This is your unit in SI system. Okay. It is a vector quantity. This type of quantity, vector or scalar. So it always be a vector quantity. Are you clear or not? Are you clear or understanding or not?
Yes, sir.
The another main point is that if it is a vector quantity, then what will be the direction of the electric field strength? Okay. So you can calculate it like the direction of E, the direction of electric field is always be same as that of force experienced by test charge. Are you clear? I mean, the direction of electric field strength always be in the direction of the force experienced by the test charge. Okay. So note it down, please. All of you have noted it or not? Hello?
Yes, sir. Yes, sir.
Should we move on?
Yes, sir.
Okay. The next point is electric field due to a point charge. Electric field due to a point charge. Okay. We are going to calculate electric field due to a point charge. Suppose that we have a charge plus Q. We have a charge plus Q, and this charge is, you can also say it is a source charge. Okay. And we have another charge at this position, and this charge is of plus Q naught. Remember that this is the test charge, and test charge always be positive. Okay. Test charge never be negative. Okay. You can write at any, on your page at any corner like Q naught is the test charge. Test charge always be positive. Remember. Okay. And what will be the direction of force acting upon this test charge? I think it will be in this direction, and the separation between them is R. Okay. Then we are going to calculate. We have already know, we have a formula E is equal to F over Q naught. What is the F? F is the Coulomb force. So we are going to calculate Coulomb force. Okay. First. Then we will put the value of force in this equation E is equal to F over Q naught, and we got final answer. So what is the value of the force acting between these two charged particles? Okay, these two charged particles. So right here, force experienced by test charge due to electric field of source charge Q. It will be F is equal to, we have already know, 1 over 4 pi epsilon naught Q naught over R square. It is a vector quantity. So what will be the direction? The direction is, okay, we are placing a unit vector for the direction. It is your equation number 1. And now, now what is the electric field of Q? For the electric field of Q, it is E is equal to, we have already know the equation is E is equal to F over Q naught. Then we can write here E is equal to, what is the value of F? It is 1 over 4 pi epsilon naught Q into Q naught over R square over Q naught into unit vector. This is a vector quantity. It is E is equal to, Q naught is cancelled with Q naught. Finally, you got 1 over 4 pi epsilon naught Q over R square and unit vector of R. This is the value of electric field strength due to a point charge. You can also write magnitude of E, or E only, is equal to 1 over 4 pi epsilon naught Q over R square. This is in vector form. Okay. You can also write it. Please note it down till here. All of you have noted it or not? Hello.
Yes, sir.
Okay, should we move on? Gauri, Nawal, Zarj.
Yes, sir.
Okay.
Yes.
The next point is, sorry, we have still some points here. We have this equation. Okay, please remember here. We are, okay, I am writing again. E is equal to 1 over 4 pi epsilon naught Q over R square. All right. It is R square. R, yeah. We can also see from this equation E is inversely proportional to the R square. Okay. So what will be the graph? What will be the graph for this equation? The graph will be like this. The graph will be like this. Just like this. Okay. And okay, this is your graph. This hyperbola represents 1 over R square. Okay. Also note it down. Note it down, please. Next example. Next example. Just 1 minute, please. Yeah. Charge plus Q is placed at origin. Then plot E versus X graph for X less than 0 and X greater than 0. This question is especially for all of you. Please try to draw the graph. Okay. I am waiting. Please draw this graph, all of you. All of you can do this or not? Hello? Hello? All of you can do this or not? Please note that suppose we have a point like this of plus Q charge. This is the origin. And now it is saying that plot E versus X graph for X less than 0 and X greater than 0. If you are drawing a coordinate like this, then what will be the X greater than 0? We have already know if this is your origin, then this region is always be greater than 0 and this is always be X less than 0. Okay, you can take two different points in both sides. This is the direction of E at this position, I mean in away direction, and the direction of E at this position is in this direction. Are you clear? And now what will be the graph? We have already know the graph between, the relation between E versus X is 1 over R square. But what will happen, it is X, you can write here, it is X. But what will happen if you are taken once X is greater than 0 and again X is less than 0. To plot this graph, first of all, we are going to plotting a coordinate frame like this. Okay. In this, you have already know, this is your plus X axis. This is your plus E. This one is the minus X. And this one is minus E. Okay. What will happen in this region? In this region, when X is greater than 0, this means X is positive. If X is positive, then we know, you can look at here, E also be positive. Then what will the positive? This is your coordinate of plus and plus. So the graph will be in this coordinate like this. In this coordinate, X is less than 0. Then if X is less than 0, I mean negative, then E also be negative. I mean in this direction. This is your minus X and minus E. All right or not? So please note it down once again. Can we move on? Hello?
Yes.
Yes, sir.
Yeah, okay. I am giving you the another examples, okay, for you. Every condition is same. Every condition is same. And the X is greater. Yeah, every condition is same. But the charge is minus Q. Then what will be the graph? All of you can draw it or not?
Opposite.
Opposite. Like?
It will be on between E2 minus X axis.
Yeah, just 1 second. In this case, if this charge is of minus Q, then the direction of electric field will be in this direction. Am I right or not?
Yeah, correct.
Okay. And now this X is positive still. Now, but electric field will be negative. And this electric field is negative. This electric field is negative. Then electric field will be positive. In this case, the slope for X negative is always be in quadrant number 2, and for X is positive, it always be in quadrant number
4.
4. Note it down. Note it down again, please. All of you have noted it?
Yeah, sir, finished.
Sorry?
Finish.
Okay, okay. Yeah. And now the another point is superposition principle. This superposition is also just like the superposition in the Coulomb's law. Okay. Superposition principle. Okay. Suppose that you have n number of charges like this. This is your charge of Q1. This is the another charge Q2. And this is another charge of Qn. And the charge at this position is Q0. Then what will be the direction of the force acting on the charge Q0? All of the charges are of same nature, like positive nature. You should draw, or you should meet all of the charges with each other. I mean, all of the charges Q1, Q2 to the Q0 first. And then the separation between them is like R1, R2 and R3. Okay. In this case, what will be the, this is for E1 and this one is for E2 and the another one is En. Okay. In this case, what is the E1? E1 is your K. Q1 over R of 10 is, 0, 1. 1 is applying force on the 0, 0, 0, 0. Yeah. R of 10, the value of electric field due to the charge Q2 is K Q2 over R20 and R of 20, like. For the nth charge, the electric field will be K Qn over Rn0. This is your Rn0. Okay. Then the net electric field at P is E is equal to E1, E2 up to the value of En. Okay. Note it down, please. Sorry, all of these are a vector. Remember here. So the net value will be the sum of the vector sum of individual electric field. Okay. net electric field at Q naught is vector sum of all vector sum of individual fields. Okay, this is your statement. Note it down, please. Note it down, please. All of you have noted it or not?
Yes, sir.
Okay, good. Now we have a question on the superposition principle. Note it down, please. This is a point of A, and at point P, it is of positive charge is placed. At this position, the negative charge is placed. This is your point T. Okay. And the normal drawn on the horizontal line is B. Separation between B and T is 0.05 meter, and it is 0.05 meter. Okay. The question is, sorry, the another point is also given at this point. This is your point B. One second, just 1 second. Give me 1 second, please. Yeah. Calculate electric field at point A and B. This is your question. Calculate electric field at points A, B, and C. Please note it down, then we will solve it. Note it down, please. The electric force acting at point A due to the point P, due to the charge at point P will be in this direction, and the force acting due to the point T, negative charge due to the point, due to the negative charge at point T will be in this direction. Okay. Now we have already know it is an equilateral triangle. In this case, the angle made between the electric field due to, this is your EAP, we can write, and this is your EAP. Okay. So the resultant field always be in the direction of plus X. Why? It is because the triangle is equilateral. So the angle made at this angle is always be at 120 degree. Okay. The whole of the angle is 120 degree. So the individual angle of both will be 60 and 60 degree. Okay. This is your field at A. And now what will be its magnitude? It will be E at P is equal to KQ over R square, which is equal to 9 into 10 raised to the power 9. What is the value of K? K is 9 into 10 raised to the power 9 into charge Q over all of the charges are Q. You can take here Q. Okay. Q over R square. This R is given 0.1 meter. So you can write 0.1 square. Okay. It will be the value of E at P. Just similarly, what will be the value of electric field at the point B? Can anyone tell me what will be the direction of electric field at B due to the point P? It is away or towards the P? It is always away from
P.
And the direction due to the charge at Q, it will be towards T or away from T. It is towards T. Okay. You have already know the separation between P and B, PB, and separation between BT is different. So the magnitude of positive charge so the magnitude of field due to positive charge and negative charge also be different at the point B. Are you clear or not? In this case, what will be the net E? Can anyone tell me what will be the net E? Net E is equal to E. You can take at E of BP, and this one is E of PT. So the E net at B will be, one second. Yeah, it will be EB is equal to E of BP minus E of PT. What is the E of BP? K Q over, you can take, what is the separation between B and P? It is also 0.05. So it will be 0.05 in the sense 0.10 square minus K. 1 second. No. It is only and only 0.05. 0.05 square minus K Q over 0.15 square. Okay. After calculation, we got this is the net value of electric field at position B. Note it down, please. Note it down, please. All of you have noted it or not?
Yes, sir.
Hello. Hello.
Not
Sorry.
noted. I noted down.
Okay. The next heading is neutral point. What is neutral point? Neutral point is a point. It is a point at which electric field of individual charges cancel each other. Cancel each other. Okay. Or in another language, you can say net field at neutral point is zero. Okay. Note it down. Also, note that neutral point does not exist. Neutral point does not exist for electric dipole. We will study further about the electric dipole. Note it down, please.
Sir, when will be dispersed?
Sorry.
When will the class be dispersed?
This class will over around within 5 minutes.
Okay, sir.
Yeah. Suppose that you have two charged particles of same magnitude. You have two charged particles of same magnitude like this. This is of charge plus of Q, and this is the another charge of plus Q. This is the central point, okay? Point at the center, O. In this case, the direction of the electric field for the positive charge placed at, you can take it A and B, placed at B is always be away. Am I right or not? It always be away, right? Away. This is your electric field of B. Am I right? Just similarly, this is your electric field away from the point A due to the point charge at A. We have already know the separation between both sides from the origin is same. Then we can say EA is equal to EB, or you can also say EA minus EB is 0. I mean, the field at this position O is 0. So this position is set to be the neutral point. Are you understand it or not? Are you understand it or not? Are you understand? Hello?
Yes.
Yes.
Yeah. Note it down, please. All of you have noted it? Hello?
Yes, and not.
Yes.
Yeah, okay, good. So we are going to over our classes today. Are you clear? And we will meet in our next class. And in the next class, we will start about the electric dipole. Electric field is